Welcome. Today I'll show you SahakarBot, an AI-powered legal assistant chatbot for Maharashtra Cooperative Societies Act. Let's start with a quick demo. Here is the chatbot interface. So let's first ask the very first question, that is, what is the process of registering a society? The query has been sent. We can see this here. And now let's wait for the response from the query. A server will respond after querying with the chatbot. We have received a response. Let's check the response. What is the process of registering a society was our question, and we are prompted with the answer and a process to register a society. Now let's try whether this chatbot can understand the context, that is, will it take into account our first question while answering the second question. So our second question would be, what are the eligibility criteria for section 25? So let's see if section 25 is in line with registering a society or not. So meanwhile the chatbot is answering our question and analyzing the PDF, let me show you what rules does it refer when we say Maharashtra Societies Cooperative Act 1960. So this is the PDF that the chatbot is referring. These are all the amendments and all the laws. You can see that PDF is 203 pages long. It has all the rules written. Yeah, so let's wait for the chatbot to answer. We have a response. We directly get a thing saying I do not know, because section 25, there is nothing called as section 25 in this PDF. We can search for section 25. 25. We can see there is nothing called as section 25 in this PDF. Okay, now let's really check the context awareness. We have asked what is the process of registering a society. So now let's check what documents are required for registering a society. So we will just test the context awareness by only this part of the question. What are the documents required? We are expecting the chatbot should understand that we are asking for the requirement of the documents for creation of a society or registering a society. Let's wait for the response. So we have received a response. So these are all the documents that would be required for generation of society or for registering a society. So we have proved that the chatbot is context aware. Now let's see if it can answer totally unrelated question. That is, let's take a question of what is an actuator. Let's wait for the response of the chatbot. Should ideally not give any response, or it should directly say I do not know, because actuator is not the context that we have provided. That is, it would not be present anywhere in the PDF. We have the response. So it directly says the word actuator is not defined in the context provided. Also note that we have given two additional contexts, that is Indian Penal Code and General Indian Laws. So none of the three had the word actuator present, so it won't be answering to this question. Now that we have seen it is so easy to interact with SahakarBot, now let's look under the hood on how everything works. So SahakarBot is built using a FastAPI backend. FastAPI that acts as a server and handles the API request. Then LangChain. Then Perplexity AI. This is just the AI model that we are using, which can easily be swapped with any other model like ChatGPT, Gemini, or Claude. or any other model available in the market. Then we are using ChromaDB that acts as a storage for our vector embeddings. We need a vector DB and ChromaDB was a good candidate. And finally, we have a React frontend. So let's review the big picture architecture. So how does the data flow? We know that we have a PDF that we need to process. So the first part is we load the PDF into the system, and for efficient ingestion we use PyPDFLoader. This is the first step of processing. Then we chunk the document into smaller parts so that it fits into our LLM context windows, and we know that LLM contexts are smaller. Then we do a chunk overlap. So overlap is necessary because we need to have context that would be related to one another. That is, the first part of the context need to be linked to the second part, and for this a small overlap is required. Then the last part is LLM input flow. Then these chunks are fed into the language models, and then they are processed for the query that the user gives. So now let's go through the actual code. First, you can see that we have imported all the required modules for FastAPI setup. So this main.py is our FastAPI server setup. We are allowing the CORS middlewares because we need access to our React frontend, which is completely on a different port, and for cross port we need the CORS middleware. We have this base model setup, and then we have this query model setup, query request, and then we have only one endpoint which only takes in post requests, and the requests would come in the form of questions and then answers. So if we already have a chat history, this are to deal with the context that we just saw, and we would see the details in the further parts of the video how the context is stored and given to the query. For now, let's just understand that the messages would be in the form of question and answers. Question is the one that user prompts, and answer is the one that the chatbot gives the response. So we have our only best method, that is the get answer method, which takes in the request.question and chat history if any. Let's see what this get answer question does. So this get answer function, what it takes in is a question and takes in a chat history. So first of all, what is being done is the initialization of the question and answer system, QA system. So basically it is initializing the chatbot. So let's dive into how the chatbot is initialized. So first of all, we have accessed the API key, Perplexity API key. We have accessed and stored it in the environment file, which is a good coding practice. So let me show you an example. We create a .env file, then we put in the same variable name this here, and the value should be your API key. This would be a hexadecimal string or a weird looking string which I cannot disclose, of course. So based on this API key, your model would run. So these are all the path settings that we have done. We have given the path to the PDF that we have in the assets folder. This is the PDF path. Now we load it using the PyPDFLoader. Once the file is loaded, we give it to a recursive character splitter. Now we have to split this into chunks of size 1000, and we have to do a chunk overlap of 150 characters so that the context is maintained. This was decided by trial and error depending on the size of the PDF and the content of the PDF. Then we do split documents, and then these pages are splitted. That is the complete PDF is splitted and it's converted into documents object. Now we access the HuggingFace embeddings. That is, we are using this model to create embeddings, that is the vector embeddings. You can change the model depending on your need, but this was the best suited model for this purpose. Now we are storing it in a vector DB, specifically ChromaDB we are using, which is a vector database, and then we are passing the embeddings and the document so that it would be stored in this vector DB. So let's see how this vector DB works and what is this vector DB. So you can see that vector DB is basically our original DB, but it works on similarity. That is, it will give you the most similar thing of the query that you have done rather than the exact matches. So let's look at the definition. Vector databases fit pieces of high dimensional data together by measuring mathematical distances, enabling retrieval based on similarity rather than exact matches. So you can see in our traditional databases, we have exact match, that is we have a primary key or where clause, but here in vector DB you get the most similar thing, and we have used this model, the HuggingFace model. So let's look at the flow chart of how the data flows in our application. So what happens is our document is converted to chunks, converted into number errors and stored into the vector DB, and then whenever we pass a query, what it does is it matches it to the similar vectors from this vector stored DB and then returns us the output. So let's hop back to the code. So this is our template prompt. These template prompts are basically the initialization of our models or the chatbot. So we whatever query that we put in here, the chatbot follows this every time. So what we have done is you are a legal assistant for society's laws. Always answer solely using the PDF context below. So it will not deviate. And that's the reason it failed, or it said, I don't know for our, that's the reason it failed and said, I don't know for our what is actuator question. You can see here. So that was because of this answer solely based on the context below. Then we have given few more things, that is we have restricted its answers and we have said it never fabricated answers, so it will not make up facts on its own. We have also defined again never make up legal content. This is legal content and it should not make up. If it is not in PDF, refer Indian Penal Code or Indian laws, or context. Context is the previous chats. And if nothing is found in all these threes, then reply I do not know. So this is our context, then PDF context goes in here. So after this, following this, the chatbot reads this, it gets the context. This context was found from here. Then it will go through the questions that we have asked. And finally, this template is the prompt template. Prompt template is a function that we came from language chain prompts. This gives us a class called prompt template. Now we initialize our model, that is setting up our perplexity model. So chat perplexity is the class. Then we use the sonar model. We give the temperature. Temperature is the parameter or factor on how the chatbot will act. So if the temperature is high, it will give out different answers for the same question, and if the temperature is low, it has some consistency. And then we finally pass the API key to authenticate. Then we use this LLM to retrieve the question answer. So what we do is we do a retrieval of QA. We pass the retriever vector DB as retriever. So this context is passed as the complete. So vector DB is stored in the context. It will search on its own. Then chain type, we give stuff, and the chain type keyword arguments is we are doing the prompt, and prompt is the prompt template that we are using. And now directly we are giving a return QA chain. So what happens is when we query, we get a QA chain. And what is present in the QA chain? QA chain has two things, query and question. Both are there. So what happens here? Let's see. QA chain will help us find the answers to the question. So what happens in this QA chain? Once we initialize this QA chain, we will get, so now we generate the context. So if the history is present, we generate it using previous question and then previous answer. So here we are limiting the previous conversations to only 3 for context lengths. I have limited it This is particularly a smaller number, but as I was just trying out and I had limited number of tokens with me for Perplexity, that's the reason I have limited the chat history. You can keep the complete chat history if you have a generous amount of tokens. Then we can see here the QA chain has been created, and then we call this QA chain object. So this basically passed a function to us. Now we are calling this as query, the question and the context that we pass. Context has a previous result if any, and then the current question, and then we pass the question. Now what do? We get the result object from this, and what is present in the result object is the answer to our chat. So then we get the answer, and then we return the answer, that is the as a response. So yeah, that's pretty much it to the code base. Now let's look at the complete flow of this bot. So how does this bot work finally? Once we have done the vector embedding and mapping and searching, we know how this worked, the vector embeddings. Now the part is, how do we integrate this LLMs? So whatever we did is, we first did authenticate the Perplexity API, the API setup by passing the API key. Then what we do is we created a template for the prompt. Template generation, that is initialize में we did the template, we generated a template and we generated a prompt template object here. Then what we did is system message role to define the model's behavior for legal assistant. So here in the template we defined the model's behavior. And then the context window management thing. Context window management we saw in our query one, where we limited the number of conversations, last 3 conversations were passed. So that's how it works. First important thing here was chat history storage, that we have enabled a chat history so that we can pass it to the context every time. Then the second one was the context window. Context window, the context window was basically, we are giving this context, and if we have given a context only when there is a chat history present. If this dictionary is empty, we don't give a chat history. And then state update process, we dynamically update the states. Yeah, so that's pretty much it on how this API works. If you have any questions, then please feel free to reach out, and you can try out this SahakarBot on our GitHub page. This is the front end, and we have a backend as well. These two are two different repositories. So backend, we know that there are fast API, and in front end we are using a React framework. Yeah, thank you so much for your time.